I hope no questions. One symmetrical frame. A is constant, right? Okay. So we found figure frames are theta B, theta C, and delta in general, plus additionally in support we are having the theta D. So four unknowns. But what are the equations we are having? Moment at joint B sigma MB equal to 0, sigma MC equal to 0, then shear equation, then plus sigma MD equal to 0. Or not sigma, just moment at D equal to 0, not both are same only. What are the moment is 0? That moment is D equal to 0 or MDC equal to 0. Not summation, MDC is 0. Okay. So here is a pin support. So no moment will be there, just MDC equal to 0. So one equation, second, third, and fourth. Four equations, four unknowns, you can easily solve it, right? So this is the initial step what we are doing for the every problem. So first one, what you have to do, you have to lock all the joints by fixed support. So when you're locking all the joints, here AB and CD we don't have any loads. So MFAB, MFBA, MFCD, MFBC equal to 0 because we don't have any load. So fixed end moments due to loads are 0. Please assume, listen, when we are starting the problem, we used to assume all the joints are fixed. This is also fixed only. We are just started assume like that, and we are calculating the forces and everything hereafter. Okay. First one is we just calculate the n moments due to the load. This is n moment due to load, external load. Since we don't have any external load, these two members are 0. Okay, n moments for these two members are 0. Next one, MFBC. So that is will be minus WL by 8. Okay, minus 50. L is 4 by 8 will be equal to minus 25 kilonewton meter. So that is MFBC. So MFCB will be, so this is anti-clockwise, this will be clockwise, it will be plus 25 kilonewton meter. So that's all. This is for loading part alone. Next one, we have tried the equations, right? Full equations. So MAB equal to MFAB plus 4EI theta A by L plus 2EI theta B by L plus or minus 6EI del by L square. The thing is, this is your frame. This is your frame. Okay. So because of unsymmetrical in geometry, symmetrical in geometry, it will try to rotate. You can see here, this is a deflected shape. You can see because of fixed support, I am putting rotation is 0. Here the straight line will be there. Here theta is 0, but here the theta will be there. So like that I have drawn here. Okay. So here delta will be there. Here delta will be there. Right. So this is A, B, C, and D. Right. Now, so when you are writing MAB, you are writing MAB. MFAB is 0. We don't have any load, so it will be 0. And theta A also 0 because it's fixed support. Then 2 EI theta B by length of the member AB is 5 meter. 5 meter. Okay. Then, so if you are having like this, so here you will be sagging. There will be hogging due to the delta. So this will be 6EA del by L square. This will be 6EA del by L square. Right? So this is anticlockwise. This is also anticlockwise. So no issues. Both will be minus 6EA del by L square is pi square. Okay. So this is the equation now for MAB. Then MBA, MFBA plus 4EA theta B by L. So I can write as a phi itself now itself. Then 2EA theta A by L, that is 5. Then minus again 6CA del by L square. So MFBA is 0, theta A is 0. So MBA will be equal to 4EA theta B by 5 minus 6EA del by phi square. Here theta B also unknown, delta also unknown, right? So that is phi square is nothing but 25. You can keep it like that. So this is the MBA. Then MBC. MBC, that member, just think like that. Member is simply straight line only. It is not, it is going, will rotate. The beam will rotate due to the loading. That external load underneath will rotate, but it is not deflecting. The straight line is again the straight line only. It is not settling or something. So delta will be 0 for BC. Okay, delta will be 0 for BC. So BC, you can see here, B is here only, C is here only. It is not settling. The differential settlement between B and C is 0. No delta, no movement from the for the joint C with respect to B. So no movement for the B with respect to C. So delta is 0 there. Then, but what about theta B and theta C? Yeah, it will be there because of load it will try to rotate. That will be, for example, it will be like that. It's like that. We'll try to rotate. This rotation will be that, the joints. Okay, because of the loading. So MBC will be MFBC plus 4EA theta B. What is your L? And this 4 meter. Then this 2 plus 2, 4 meter. Plus 2EA theta C by 4 meter. Then plus or minus 6EA del by L square. So you know that it is no differential movement, any settlement. So it is 0. B and C, yeah, it's a joint. Surely it will rotate. We don't have any rigid support here. So that will be there. And MFBC, we are having loads. So they are having values. Finally, MBC will be equal to, this is minus 25 plus, cancel each other. EA theta B will be there. Theta B is unknown. Again, I can cancel here 1 by 2, 0.5. EA theta C. This is a one more equation. Okay, so I can write it. This is okay. This is 25. This is 1 MAB. MBA 2. This is 3. So like that, MCB will be positive 25 plus EA theta C plus 0.5 EA theta B. That's it. Simply it will interchange. That's all. The values will interchange. Other than nothing. 4. Okay. Here also delta will be 0. Instead of 4A theta B, here theta C will come. 2A theta B, C theta B will come. So that is just changing. Right. Then what is the other thing? MCD. MCD, MFCD plus 4EA theta C by L. What is L? Length of column CD is 4 meter. is 4 meter plus 2 EA theta D by L. 4 meter, then this plus or minus. So this is here. Just assume again as we logged already is support, right? So it is settling here. Okay, it is getting settling here. So the delta will be there. So when its delta is like this, so here again anti-clockwise, anti-clockwise delta. So I can put minus 6CA del by L square is 4 square. Right? So 4 will cancel here. 2. What is MFCD? MFCD, MFDC are 0, right? So it will be 0. So finally MCD will be equal to EA theta C plus 0.5 EA theta D, then minus 1 by 4. So sorry, not 1 by 4. This is 16, 6 by 16, right? 6 by 16 EA delta, right? EA delta. So I can write 3 by 8. So MCD will be equal to EA theta C plus 0.5 EA theta D minus 3 by 8 EA delta. So equation number 5. So then what about MDC? MDC will be equal to MF DC plus 4 EA theta D by L plus 2 EA theta C by L minus again same 6 EA L by L square will come, same minus only. So the thing is that he had to interchange it, that's all. This will be 0, right? Now you can't make theta D as 0 because theta D is unknown here. Theta D is unknown here. Okay, that's why here also we didn't cancel. Theta D is unknown. Okay. So MDC will be equal to 4 EA by 4. This also will be 4. So EI theta D plus 0.5 EI theta C, then minus 3 by 8 EI delta. Right? This is equation 6. And then another one, I can make it equation 6 as also 0. That is MDC equal to 0 will come. That we can follow it. And then if you want to make it, that also we can make it now. That after that also we can do that. Okay. So now we have found all the moments with respect to theta B, theta C, and delta. So what is your next step is go to our joint. Okay, before itself we have finished here. We have MDC equal to 0, right? Because of pin support. So because of pin support that is 0. So you will have EA theta D plus 0.5 EA theta C minus 3 by 8 EI delta equal to 0. Okay, delta equal to 0. So if you want to divide the EI, if you want to divide EI from here, and if you multiply the 2 theta D plus 0.5 into 2 will be 1, so that will be theta C. I'm just multiplying 2 by EI here. So then minus 3 by 4 delta equal to 0. Okay, this is my equation number 7. This is my equation number 7. Then adjoint B equal to 0. Moment at adjoint B, moment about B equal to 0. So you will have MBA plus MBC equal to 0. So what is MBA and MBC? MBA and MBC. What is MBA? 4EA theta B by 5 plus, sorry, minus 6EI by del by 25. 6EI del by 25. Okay. Then BC minus 25 plus EA theta B plus 0.5 EI theta C equal to 0. Okay, equal to 0. So again, you can make it as a theta B, theta C, theta del, and you can make it 25 by EA also. you can divide the A and it will become as a 25A. Okay, so that is one more equation. Okay, you can keep this as equation number 8. You will get one more equation. Then I like adjoint C. If you are keeping MC equal to 0, so MCB plus MCD equal to 0. Then you are keeping like that 25 plus EA theta C plus 0.5 EA theta B. Good. Then again CD will be EA theta C plus 0.5 EA theta D minus 3 by 8 EA delta. Okay, that is CD. Which is again equal to 0. So this you can make it as equation number 9. So 1, 2, this is also 3. Then what is another equation? Another equation is shear equation. What is shear equation for this frame? What is shear equation for this frame? What is shear equation for this frame? For this member AB, so will be MAB plus MBA by this H1 means H1 side of the column, or I can keep it a side of the column AB. Okay, and then plus this one C and D, MCD plus MDC divided by HCD. Okay, then any other things are there? No lateral horizontal loads. So this will be there, sigma H equal to 0. So this is your direction. This is your HA and HD. So we have done HA and HD. Right? So now the thing is, just apply the value here. What are the values? MAB plus MBA and MCD plus MDC. Just substitute and simplify the values. Again with respect to theta B, theta C, theta D and everything. Okay. So when you are making like that, finally you will get equation as EI 0.24 theta B plus 0.375 theta C plus 0.375 theta D minus 0.28 delta equal to 0 delta. This to it. Okay, this is equation. This is shear equation. You will get like this. So this will be equation number 10. So now we are having equation number 7, equation number 8, equation number 10, 9 and 10. 4 equations, 4 unknowns. How will you solve? 4 equations, 4 unknowns. How will you solve? Which method will you follow? Which method will you follow?
Sir, matrix method we can use.
Yeah, you can use matrix method also. You can do that, right? Have you done in your mathematics class? Have you done in your mathematics class?
Yes, sir.
Okay. So 4 equation, 4 unknowns. Just find it. Another one simple idea is you can go for. Do you know Gauss serial iteration method? This one, have you heard about that? Gauss serial iteration method.
Yes, sir.
Already you heard about it. Guys, do you know about this method?
Yes, yes.
We can follow that also. You can finish it. Okay, so finally you will get the values are theta B 20.43 by EI, theta C minus 19.14 by EI, theta D 13 by EI, and delta 9.19 by EI. Okay. And substitute again MAB, MBA, all those things and all, when you will get MAB equal to 5.99 kilonewton meter, MBA equal to 14 kilonewton meter, MBC equal to minus 14.13 kilonewton meter, MCB equal to 16.07 kilonewton meter. MCD equal to MCD minus 16.07 kilonewton meter. MDC equal to 0. When you are substituting, you should get MDC as 0. So then you can say your answer is right. And at joint C, it should be 0, and joint B also it should be 0. Then your thing is perfect. The thing is perfect. Okay. So you just check it out, check the answers, and let me know on Tuesday class. So answers are you are getting or not. Okay, and draw the bending moment and shear force diagram as it is. Right. So this is one thing what I want to discuss here. Any other questions in this problem? Any questions? Okay. So now I'm giving one problem. Just solve yourself. See here, I'm changing the second moment of area also. So be careful when you're applying the equations, right? Solve the problem, solve the frame, and find the shear force and bending moment diagram. So you will get the answers, or I'll just share the answers also. Answers. So how many degrees have we done the here in this equation? How many are there? Degree of freedom. This problem. Guys, how many degrees of freedom are there? Guys? Sir and madam, how many degrees of freedom? This problem. Both are fixed. So no degree of freedom for this support. Here at B, theta B will be there. At C, theta C will be there, and overall sway also will be there, right? Theta B.
4, sir.
4. What is another one?
Sir, vertical displacement, BC.
BC, no, it won't. Because it's just a normal frame, it will go like that only.
Okay, okay, sir.
Like that only. Right. 0.41 by EI. Theta C will get minus 0.044 by EI. And finally, delta will get 1.42 by EI. So just try it. You are getting these answers. If you are getting this degree of freedom values, you can substitute MAB, MBC. You will get the proper values. Okay. This video, this lecture whole presentation, I will upload into files. MS Team itself, we can get from that also. Okay. So Tuesday, you will see some gable frame kind of thing, how it is solve different type of frames. Okay, in slope deflection method. Then we will move on to moment distribution method. Okay. We will try to finish it on February itself, moment distribution method. And then balance will be only ILD, that we will see in March. Okay, I will try to finish your syllabus as soon as possible. We will have many tutorials class. Okay. Any questions? Do you have any questions? No? Oh yeah, people silent today.
Sir, can you suggest some book for practice, sir? Practice sums.
I suggested. You didn't get the books?
No, sir.
No. Risha, I have informed you, right?
Sir, I
Have
told.
you shared the book's name?
It was sent to the group, sir.
Yes, okay. So the Hibbler, RC Hibbler, for this kind of, there's a fine author, these frames you will get it. Okay, slope deflection method, moment distribution method. And previous one, right? Fixed beam, only fixed beam, those things you can get from R.K. Bansal and Ramamridam. Both are good authors only. You can go and check with them for fixed beam. Fixed beam and propped cantilever, those books are good. For slope difflection method, you can go ahead with R.C. Hibler, structure analysis. So many problems will be there to do the practice. Okay. These are author names. You can go type it in Google, you will get it. So, just stop the record.